Alright, we also need to know what a conditional statement is. I can write conditional statements and understand their parts. Alright, so we need to know inductive, deductive, and then be able to write conditional statements. These are introducing proofs, which is, we're going to do some proofs here. A conditional statement is a statement that can be written in this form. If P, then Q. Alright, where P is the hypothesis, if the hypothesis, and Q is the conclusion. For instance, down here, all zebras belong to the genus Equus. I could say, if it is a zebra, comma, there's my hypothesis, then it is of the genus Equus. Conclusion. Alright. The bill will pass if it gets 2/3 votes in the Senate. Alright, so I could say if the bill gets 2/3 vote in the Senate, comma, then the bill will pass. And that is called a conditional statement, which we have to know. Alright. Closing task. A rhombus has 4 side lengths. I could say if the figure is a rhombus, comma, then it has, right, 4 equal sides. We'll go a little bit more. Alright. So, for example, conditional statement, if 3x plus 5 is 13, then x equals 6. The hypothesis is if 3x plus 5 is 13, and the conclusion is x equals 6. Now, these are important. Right here. These are important. We should probably take a list of these and put them all together somewhere, but these are called properties of equality. And the reflexive property we're going to use a lot. The symmetric property we're going to use a lot. Right? You should say equals here. A equals A equals B, and B equals A. My equal signs aren't printing off very well on this printer, but those are all equals. Transitive property we're going to use a lot. Substitution property we're going to use a lot too. Alright? So, I'm going to show you some stuff right here. I can use deductive reasoning, and we're going to do these next two here, right? And I might bring this back in. Alright? So, to solve the equation, use the properties to justify each equation. So I'm going to add 4. Add 4. That is the addition property of equality. So I'm going to say, I'm going to write it shorthand, add prop equal. Just like that. And I get 18 equals 3x. I divide by 3. And that's the division prop equal. We get 6 equals x. So we're not just doing the math, we're stating the rules. This guy right here subtracts 17, and I get negative 8 equals negative 4x. That's the subtract prop of equal. And we divide by negative 4, divide by negative 4, we get 2 equals x, and that's the division property of equal. And those are ones you know, the properties of equalities. And you come down here, right? X equals 2, then 2x equals 4, right? So that's the multiplication prop of equal. Because look what I did. All I did is multiply both sides by 2. Alright? If 5a equals 3, then 3 equals 5. Well, that just says all I did was reverse them. So I look over here, and here it is. Symmetric property of equality says if a equals b, then b equals a. I reverse it. So that one's the symmetric property of equality. Alright? If t equals 4, st plus 7 equals 27, or 5t plus 7 equals 27. So what we've done is we've taken this 4 and plugged it in here and done our work. So the main thing we've done is we've substituted, right? If a is b, then b can be substituted for a in any expression. Well, if t is 4, 4 can be substituted. So I'm going to say substitution prop of equality. So these are all our properties of equalities. If 9 is 4x, 4x equals 9. Then 9 equals m. Alright, so look what it says. Alright, this is going to be a transitive. If a is b and b is c, a is c. So watch me say that here. If a is b, this b is c, then the original m, a, is also c. So that is called the transitive prop of equality. Okay? And we're going to stop there, and I'll be right back.